Welcome to another episode of ValueFirst Expert Interviews, and today we are very happy to have Mr. Simon Wright, and he is a Systems and Software Requirements and Estimation Practitioner.
Yes.
Welcome.
Nice to see you.
Nice. Okay, we'll talk about systems and estimation and requirements and succeeding in projects. Simon has some quite amazing experience with the Norwegian military
Army,
Army acquisition of we'll get to that. But before that, let's take a few steps back. When you were a child,
yes,
10 years, 12 years, something in that area.
A long time ago, yeah.
Long time ago. Who was Simon? What did you like to do? What was your hobbies or interests?
Cycling. Cycling was, I can remember as a 5-year-old actually teaching myself to ride a bike. Mm-hmm. And from then I would cycle to and from school. At college I was the guy who was cycling to and from lectures, and when my kids were old enough I would take them out on cycling trips, and now I'm an ancient guy. In a few weeks' time, I'm going to take 3 of my granddaughters out cycling. So wow. I enjoy cycling.
And when you were at that age, young child, exact age is not the point, but were there somebody in your life that were like an important influence on you?
Apart from my parents, which obviously were the major influence on my life, I can think of a couple of teachers who helped and encouraged me. In the UK, we used to have a test when you were 11 years old to see if you went to the grammar school would lead to university, blah, 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 or you'd go to the more vocational based. Right. I failed at that, and I went to the more vocational. Yet, I was a late developer. So, possibly one person was a careers master who at the vocational school said, well, he's not going to do much. And I thought, he's wrong. And so I went on to do my university entrance and got in. I did my BSc and then I did my PhD, so I'm a Dr. Wright. But I don't use that often. But it was, so maybe, not so many people, but some things people have said, oh, he won't do that or couldn't do that, and I think, well, maybe that. So maybe I like proving people wrong.
So maybe the big influence was somebody actually giving you like a negative.
Yes.
And then inspiring you to say, hey, I remember
what do they know about me?
Right. And when you got a little older, you did your first sort of decisions about what path to take in education. What were your choices, and do you remember why?
Choices, absolutely. My choice was to study chemistry. And for me, I'm a very spatial person, and I see patterns. And the thing about chemistry is that it happens in the mind. With physics, you can feel an electric shock, or you can feel heat or light. But within chemistry, these atoms, you can't see them. You have to imagine what's happened. You can see the outcome. You can see the beginning, you have 2 chemicals, and you mix them together and you get a third. You see the input and the output, but what happened in the middle? You know, you have to work it out using your mind. So when I came to, when I was looking for a new job, and there weren't very many jobs in chemistry, and there was lots of jobs in computers, I actually found that computing is a bit like that, because you put inputs in and something would happen, and you get some outputs, and sometimes you didn't know exactly what happened in the middle.
Magical.
So yes, that's, so I was drawn to the sciences, particularly, as I say, chemistry, but then that evolved later into systems and software.
And that's the area you are in now?
Absolutely. I'm in systems and software engineering, and as your lovely introduction said, I'm a practitioner. I like doing it. I don't like managing it. I don't like administering it. I like actually doing it. I'm a bit of a doer.
Right. Now, earlier at our conference, you were talking about a very exciting project that you were involved in. Maybe it's better you.
Well, yes.
Tell us something exciting about that.
Well, it was interesting because it was. I started back in about 4 years ago, where I was asked if I would like to help develop a specification for a new military vehicle. And this is me liking a challenge because they'd tried to develop this military vehicle for about 10 years and they'd been a complete and utter failure.
Yeah, so 10 years of
failure.
Right? Lots of effort, no output.
Absolutely. And I think that it was for the Norwegian Army, and the people I spoke with, the project manager, he knew that what they were doing before didn't work, and he wanted a new way. And for me, I look at the systems engineering process, and I've used it in many projects before. I know it works. So when I was offered the opportunity to do this work, I said, okay, but you have to do it, well, I said my way, but it's not my way. It's a standard systems engineering course. So we started off...
Before
yes.
we go there, do you know anything about what didn't work? Like there were 10 years of...
Oh, it was
working.
not working.
Why? Why? What did they do that was silly?
I'm going to be honest, I didn't know much, and I did not investigate. And I made a conscious decision to find out what didn't happen, or why it failed. Anecdotes came out, lack of user involvement, which we all know is the number one reason why projects fails. Lack of a clear set of requirements, that's the second reason why most projects fail. So I knew in my heart that the previous project, there were standard things that I knew I could fix.
So lack of user involvement and lack of requirements are almost the same thing. There's a requirement from the user.
Correct.
And except there are other requirements as well than the users, but it's like
Indeed.
that's one type of requirement that was it, yeah?
Absolutely right. But in any project, requirements evolve.
Yeah.
And therefore, it's not just having the user involved at the requirement stage.
Right.
During the evolution of the project, you've got to keep the user close to you.
Right.
And that way, you keep on track. And believe it or not, requirements do change. People like to think they don't change, but they do.
Clearly they do. So
because as you investigate...
Some of the benefits of being able to work in shorter cycles is to be able to take into account the learning. For me, they not only change, but also at the same time, your understanding of them changes.
Yes, absolutely.
So I always envision in the beginning, you have some vague, unsharp, over there somewhere idea of where you want to go. And then as you get along, you're trying to get a sharper and sharper idea, a better understanding of where you need to go. And it's moving. The target is moving.
Absolutely.
So you need to move after it. If you don't move after it, you're going to end up over there. Well, the new requirements, what you're going to deliver is over there. So.
Absolutely right. When you look at the textbooks on requirements, people will say, well, you elicit requirements. So that's like you go to somebody and say, what are your requirements? But actually, they don't actually know, so you can't elicit them. Somebody talked about gathering requirements, like you gather flowers. You could just go and pick them up just like that. And there's various metaphors for that. A book that I greatly esteem is by Ian Alexander. He called it Discovering Requirements.
Do you remember the title of the book?
Discovering Requirements. Okay. Yeah. That's it. Yeah. And that's his paradigm. And I thought that's exactly what it is none of us really know. We've got some ideas. And it's a discovery. It's a journey of discovery. As you say, it's misty. You can't quite see. You go to a place. You look around. You just say, well, it's got to be able to do this, and this, and then you discover as you go along. So for me, a requirements and development is a discovery process. And the thing about it is, I'm always surprised.
Yeah.
And that's why suddenly you get to a place where you think, oh wow. And that wow factor is often happened in our requirements discovery process.
So now back to the Norwegian Army project.
Yes.
I cut you off a little bit.
That's okay.
A little bit, like, let's not move too fast. But now let's go into, so what did you do? Your way or systems engineering way, as you say.
Okay, so first thing is stakeholder analysis. You've got to know who the stakeholders are. And again, I use a model. It's again Ian Alexander's model called the onion model. And I've used it many, many times, and I know it works.
Very briefly, what is onion?
The onion model, it says at the middle, you've got the object of interest. And then the next layer out is the people who physically interact with the system. So that's the users, the maintainers, and the supporters. And then the next, that's the system, because the user is part of the system. That's a fundamental thing.
Right.
And again, people forget that.
Right.
And then the next layer out is the containing system.
So, just because I'm done.
No.
So, first of all, I didn't quite get the inner layer, but before that...
It's an object. The inner layer is an object.
What example?
The military vehicle.
Okay.
The military vehicle is the object of interest.
Okay, so also another word would be the product or service.
The product or service,
okay.
Exactly. But without people.
Right.
The next layer out, you look at the people who actually physically interact.
Right.
So that would be the user for the military vehicle, the driver, a navigator, or a weapons guy.
Right.
But also maintenance. Maintenance, when it breaks down, it's maintained.
Right.
And also there's support, like logistic support to replenish things. So it's the people who have a physical interaction with the object of interest, and that is the system of interest.
Right.
So that's the first layer. Then outside of that are what we call the beneficiaries, the people who benefit from having the system.
Right.
Now they may not actually interact physically with the system, but they get benefit from the system being there.
Right.
And then that layer model builds out.
Yeah.
And you think about then who can represent those people. Now the best thing is, can you get? So we identified, for example, the commander of the vehicle. Right. Well, we got a commander to be involved, and that's so important that you have the actual user. And you have to be there. If you can't get the actual user, you often have what we call a surrogate. And many people say, "Oh, we don't need to talk to them. I know what they want." I always worry when I hear "I know what they want." I think, are you sure? Because you tend to. It's very difficult. I've tried to act as a surrogate when we can't actually have a user, and I find it difficult. If I don't have the detailed day-to-day experience of operating a system, do I really understand it? And I don't think I do. So the object of the stakeholder analysis is to identify the users and beneficiaries, so that you can then involve them in the discovery of the requirements.
Right. This, by the way, is very similar to how we do it.
Oh yes, absolutely.
With a product level, you call the object.
Yeah.
And then the stakeholder level, and then the business level is non-in. It's just different words. Exact same thing.
You could call it layered if you want it.
Yeah, for me it's the exact same thing.
Yeah.
Different words.
Yeah, it's a model.
Yeah.
Some models, all models are wrong. Some models are useful.
Yeah.
So after that, we then said, well, what is the life cycle of this vehicle?
Right.
And we did a life cycle chart. And the interesting thing was that we started off, the very first was, we said, well, it's the operational life cycle, so the supplier will deliver a fully working machine to us. And that's where we started, and we realized that then it's delivered in a parked status. Yeah. And then, because it was a vehicle, it would then drive to the area of operation, so there'd be some transportation or self-propelled. If it broke down, it would become maintenance. Had to be maintained. Sometimes these vehicles have to be towed back, so there's a recovered state. But most of the time, it's operational, and that's what we started with. And this is where the discovery came in. We went on as we developed the requirements. I suddenly realised that there was a large number of pieces of equipment which because there's been a 10-year development, there were a number of components that were to be used in this new vehicle. They already had done some development. And I suddenly realised, and it was about halfway through, I'd missed a key life cycle element, which was what we called the procured state. They would buy the vehicle, but then all this other equipment would come in to be like a GPS antenna. They already had GPS equipment, and they already had some radios they wanted to use. So that was it was a great delight. We discovered a life cycle state which we'd missed on the first analysis.
Right.
And if we don't do these plan, do, check, act cycles,
Yeah.
That's what you miss out. It's very difficult to get it right at the very beginning. You have to always check to see whether or not you're progressing. So we discovered this new life cycle state, and then that meant we had to go back and check with, we missed a stakeholder as well, like the procurement people, because they're going to buy this thing, and we've got to tell them all the equipment that this new vehicle has to be able to accommodate.
Right. And it is obvious when stated that if you miss a stakeholder and
Yes.
their needs and their requirements,
Precisely. Yes.
you fail.
You fail.
Right.
Absolutely. Yes.
So it's so critical that we have a proper process where we go and look for all the stakeholders that have demands and needs for our products and services.
Absolutely.
It's so obvious, but not everybody does this. So
Yes,
we need to
but this is why you need
state
short cycles
to
really
learn.
check each time,
Yeah.
and you say, and it seems like you have to go back to the beginning again. Did we really cover them all each time?
Yeah.
But you just miss one. You miss vital requirements and system facts. Absolutely. So having done the life cycles, then for each of the individual life cycle states, we did a context diagram, because fundamentally systems theory is the boundary of the system. What is in and what is out?
Yeah.
Oh, there was a lot of arguments.
Yeah.
Some people's picture of what they were getting differed from others, other users, and through negotiations and workshops, we got to a definition of what was in the system and what was outside of the system.
Right.
And that's very, very clear, because once you've got the boundary, you then have all your interfaces to the cooperative systems.
Right.
And particularly when it came to the procured state, this is what we were buying, and we had all these individual bits of equipment which had to be added, and then for every single one, we had to have an interface control document, which was a new document to the people I was dealing with. And that was key and crucial to being able to specify to the people the bidders, what they had to do. We were able to have these interface control documents. Yes, we want this vehicle, but it's got to be compatible with this radio. And here is the size, the shape, the power, the vibration requirements for all these things. So again, we discovered, we discovered what was in and out of the system. That again was very important. And again, we had to check. And if we found a new piece of equipment, which we hadn't covered before, guess what? You need another stakeholder.
I think it's so important. Most people that does software, for instance, maybe they're doing some Scrum method and they have, some user stories moving along. I'm not sure they always capture this system view. They're more like they're developing their product, their program or something. Now, when you have a big cannon with everything, you obviously need to do the systems view, otherwise you're going to fail before you start. But I think the same is true with even like if you're a software house. You have to, if you truly want to succeed, you have to think about the whole system surrounding it, and all the stakeholders and all the other products it has to interact with.
Yeah. Because each one is an interface, and you need to have a clear understanding of what that interface is. And I bet you that when and I've had it before because I've done a lot of software engineering,
right.
I would say, what is the boundary?
Right.
And some people imagine that certain functions are in this particular boundary, and others assume that it's not out. And unless you have because we work in teams, and it's so important to have good and clear communication within teams, we all need to know what is in and what is out. And if it's out, is it somebody else's responsibility? And then with an interface, you've always got two sides of the coin. You can't just say, well, my interface is this, you have to comply to it.
Right.
You need some discussion and negotiation, but who with? And if you haven't identified the stakeholder for that particular component, you've got problems.
Yeah. Okay, now you did some semantic wizardry
yes.
with all these requirements that you specified.
Right. So having developed a list of stakeholders, a list of states and actions, having got a set of contextual information with interfaces, etc., it gave us a whole lexicon, a whole glossary of terms. But then we need to convert those into actual concrete statements of requirements. Now, this was for the Norwegians, and the suppliers were going to be France, Switzerland, Germany, and South Korea. Now, for all of them, English is their second language. So I gave, we started off with a very rigid syntax on how we would express something. So we'd always say, the system shall do something on something and output it somewhere at a performance level.
Right. Very specifically, right?
This
was not just like blah blah. This was a very specific structure you laid out.
Absolutely,
right?
a syntax that we laid out for the people who were writing the requirements to help them in their mind to structure a clear English statement that had a very clear definition. What was the function? What were the inputs and what were the outputs? What were the performance criteria? What was maybe the triggering event? What were any particular conditions that had to be? And it's just a checklist in the form of and you end up with quite a long sentence.
Right.
But we then use some natural language processing tools to make sure that we had followed our own rules. Because, particularly in English, a word can have different meanings. An example I always give is I want to book a book from the book library.
Yeah.
And the word book in English have got three meanings.
Right.
A book is an object.
Yeah.
To book something is an action.
Yeah.
And a book library is an adjective. So,
right.
so you've got to be clear that each individual English word had a single meaning, and you couldn't use it to mean something else. And English is a difficult language.
So how did you do that in practice? You had a common definition word?
We had a common definition. We developed a knowledge base of words, whether it was a verb, a noun, or an adjective, or a compound noun, etc., or an adverb. And we had then, within the tool, we could set rules that you always had to have the and then a noun.
Right.
And only a set of nouns, which were the agreed set of nouns for that system, which was quite a long list.
Right.
Shall.
So then you had this semantic rule lists.
Yes.
And then they started writing. And I've seen the
was
document specification is.
It was the other way round.
It's this thick, right?
Yeah, it was this thick.
Like
about a third of that was all the technical specification.
Right.
So we had a third which was legal,
right.
a third commercial, and about a third technical.
Right.
And it was all the technical stuff.
This is for acquisition.
Precisely.
So the development happens later.
Yeah, absolutely.
Yeah.
Yes, absolutely. So once that technical specification is completely locked down.
Okay, so sorry, I wanted to go. You said it's the other way around. But what was the process? What I'm looking for is actually how well did they do when they started specifying?
Dreadful! Absolutely dreadful. The first set of requirements we had were when we put our measures of quality on it. It was over 60% bad. But that was okay because we only had about a quarter of them written. So then I had to put my editor hat on and edit them and show the writers how we were going to do this.
Right.
And slowly over time we increased the number of requirements, but it took 3 or 4 weeks to actually get the mind round to how you write these clear, succinct value statements, these requirements. And slowly, as the number grew, slowly but surely, the percentage of high quality increased and the percentage of medium and low quality reduced.
You tracked this, right?
And we tracked it throughout the whole of the period.
We got better and better.
We got better and better and better at it by practicing.
Right.
And by having these sort of like 2 or 3 week cycles where we would review, people would see how they could get better, and they learned. And one of the biggest successes that the project manager said was, at the end of it, the engineers were better at expressing themselves than they were at the beginning. Yeah. So yes, we got the spec out on time, but also there was a knowledge transfer, and people had a better understanding, and they could see how this process and they could see the benefit of having the user involved as well, because I insisted upon it, and they saw the benefits. So yes, it was. At the end of it, the team were better in a better position to do the next project.
Right, fantastic. Now, so before you, there were 10 years, and they didn't manage. Now, how long time did you spend, and did you?
We had to write the technical spec in 5 months.
5 months, but they didn't manage to do it in 10 years.
No.
Yeah.
So actually, the timescale I found out was actually 6 months. But if you tell somebody it's 5 months, they're always a month late. So we got it done in 6 months, and we sent it off to the suppliers, and they all came back, and they all said they actually understood what it was we wanted. Yeah. And that was a great benefit. Because this is the problem, when I want something, I have a concept in my mind, and I've got to get it onto a bit of paper for you to read, and I want the same concept in your mind.
Right.
And
as you intended.
As we intended. Now, that's not to say that every single requirement was of the highest quality. We still have some which were, I would say, low quality. They tend to be fairly long, rambling ones. Right. But it wasn't a perfect specification, but the question was, what was the risk going forward? And the risk going forward was very small. All the major areas we have planned out and expressed in very clear, definite language. It was not so important areas where the quality was not so high. So we don't aim for perfection. Think about what is the risk of going to the next step. The next step was to distribute it, and we got it to a point where we felt it was ready to distribute. And
at that point, some ministers put the pen to paper?
They had to respond to it.
Right.
And another really key element to this was what we called technical readiness levels. So for each individual performance requirement, so say the vehicle had to have an average of 60 kilometers an hour. Yeah. We asked them, your solution, is it technically ready? And we used a 9-point scale, 1 to 9. It's a standard thing called technical readiness levels. You can look it up on the internet. And the thing about it, we said, if it's 7 or above, that's good. Because level 7 means you've done a documented test. And so when we got them all back, we said, right, let's look at which one is the most technically ready. And some of the responses, the vehicle that they were proposing was technically ready. Others, there was some development work to be done. Now, the previous project, 10 years of development, no result. We really wanted the absolute minimum development. If it could be off the shelf and it was good enough, we were going to take it. And it so happened that we were fortunate. One of the solutions was technically ready at the minimum performance level.
So how much was the cost price?
Back in 2017, towards the end of the year, we got one of the suppliers back. And we said, right, are you willing to sign technically on every single one of the technical requirements that you can do this? And we wanted them to be honest with us, and they signed off on them all. And in December the 20th, 2017, a $380 million contract was signed.
All right.
That's
quite. Then your job was done.
Then my job is done.
Now, but what happened afterwards?
Well, then they went to do the development work. So they had a critical design review, and there were just 4 critical design items. When they went to the next review, that's down to 1. The vehicles are being built as we speak. they've gone out to the supplier to do what's called the first article acceptance test. That's to prove that it works. So this is 2019 summer.
Right.
So they've only had 18 months to get to this point. But because the development work was minimal, we had minimized it by doing the TRL levels,
Right.
and yet we know it's going to meet the performance we require. The first vehicle will be delivered this year in about October, November, and the project is on time, to spec, within budget.
It's possible.
It's possible.
You see, almost nobody does that, right? I mean, especially on big systems
On
like
big
this,
systems
almost
like that.
unheard of.
Yeah.
So, congratulations just on
Thank
being
you.
part of that.
Well, I'm just part of a team.
Yeah.
There was a lot of team members, a lot of people who worked together.
Right.
So
Now, you work together with many people over your
yes,
career.
absolutely.
Is there one person that you work with in any other this project, any other project, which really fired you up or got you interested or challenged you or
Yes, I can think of one person.
Yeah.
I'm looking at it.
Me, we didn't work together.
No, we haven't worked together. But I went to about, probably 10 years ago, I went to one of the presentations. And you got up and said there's no new functions.
Right.
Which is one of your big things. I thought, this guy's crazy. And it made you, that thing, there are no new functions, made me think. And then I read more about Tom's work as well. And I found that those radical things, they've made me think. So definitely the Gilbs have been one of my influences. And another one was Professor Barry Bean, who is here today. That's the estimation side of my work. When I read his work on Kokomo, which is many years ago, again, it was bringing science to what was a software. I'm an old guy. I remember when software was a black art, and he was trying to bring some science, some discipline, some numbers to software development, and so I followed him for some time as well with the work with Kokomo 2, Cosismo that I've used as well. In fact, at the end of the Norwegian project, we looked back and we used the Cosismo model coming out of the same university as Professor B. And we worked out that we actually generated this document 40% cheaper by using a proven discipline method than if we just all got together and wrote stuff.
Right. So it's so great to have the professor here.
It is.
And it's such an honor. And we managed to do an interview with him too, which I'm really happy about.
I can't wait to see that.
So, yeah.
But yes, I tend to read, and so there are some seminal books.
Right, and that leads into my next question. Is there any books that has affected you that you'd like to recommend?
Oh gosh,
yeah.
I need to think about.
I haven't given you any. Okay. Well, let's think about that. Let's go. So, if you're a young engineer, or not necessarily yet an engineer, a young person now saying, I would like to be in product development, engineering, maybe software, maybe other things. What path would you recommend them to take? There are many paths to.
Yes.
Or if it was you, right? If you were to be young again, right? What would you do? Is maybe a better question.
I think take the opportunities when they arrive. So I've been very blessed, and I've had various opportunities which I've grabbed, and I've worked in big companies and small companies. I've worked on medical devices. I've worked on a particle accelerator. I've worked on nuclear power plants, and all these. I hope nobody watches this, but for example, when I went for the medical devices, they said, do you think I could do this? And I thought, I'm going to have to say yes, but I'd never worked on medical devices. But I knew the process. You see, the process works.
Right.
If you have a clear process that that works, something like Evo or Agile or whatever it is,
Yeah.
if you know that works, it should be applicable to whichever technological area you're in, if it's a good process. So I always think about the process and making sure that I understand that and follow the process. So far it's led me to some very interesting areas. So don't be frightened. Get experience, and of course, and each time I try to choose. I've been again very blessed. I can choose interesting projects. Somebody says to me, "Would you like to do this?" And I think, I've done that 2 or 3 times, and I'll say no. But if they say, "Oh, here's something interesting," would you? If there's something that I haven't done before, I think, well, I'll try that out. So don't be afraid. Have a clear, proven, successful process at the back, and apply it to those new experiences.
Wonderful. Now, I'll give you a little bit more time to think of a book or two.
A book or two. Okay, well, a book that, I'll tell you my favourite book.
Yeah.
Godel, Escher and Bach, The Eternal Golden Braid by Hofstadter. And it's
There's a lot of words. What we'll do is we'll provide a link to that.
Right, that is a really tough read, but I mean it's Godel, Escher and Bach. These are 3 people who, from different areas, but they see patterns. And I think that's what I see. When I see things, I see patterns, and it's an encyclopedia of interesting stuff.
All right, thank you. Now, if anyone were to want to get a hold of you to maybe use your services, how does one do that?
LinkedIn. That's how we do it nowadays.
So we'll provide a LinkedIn link,
Very kind.
video, and then if anyone wants to use the services of Simon Wright, then you have that access.
Thank you very much.
Thank you very much. Fantastic.
It's been a
Really
pleasure.
appreciate listening to all your experience. Fantastic. Thank you.